Hello, my name is Brett Wynn, and I want to welcome you to my cyber analysis platform, ThreatScope. Securing a network can be a daunting task. Many users have to manually run network scans and sift through dense and complicated reports to understand their actual risk. But that's why I built ThreatScope. This cyber analysis platform automatically maps your network, investigates dangerous vulnerabilities, and delivers a human readable report with remediation steps. This is the ThreatScope UI. To get started, all the user has to do is input a target subnet. For this demo, I will be using the internal Docker network. And when I hit run, instead of like a standard scanner that will just dump raw data, an autonomous agent will be spawned, which will think through the process in real time, as you can see. The scan is complete now, and as you can see, the agent logs all of its thoughts and actions. And at the very end, we get a final report that summarizes the findings, the vulnerabilities, and gives the user recommended actions to address the vulnerabilities. This is the system architecture. In the bottom left, we have our target, which is Metasploitable, and that is an OS that is pre-configured with a bunch of network vulnerabilities. And for the actual scanning system, we're using a Streamlit front end. Our backend runs the scanning engine and the agentic React loop. The agent uses an LLM and pulls from a public common vulnerability database using an API. And as we pull common vulnerability IDs and descriptions from that API, we store them in a RAG database locally so that we can save time without having to use the API for future scans. And our Postgres container stores historic scan reports. One element that I want to focus on is the agent design. So the agent has been given a handful of tools. The scanning tools that it can use is a network sweep in order to discover hosts on the network. It can also do a port scan to find open ports on those hosts. And then finally, it can perform a vulnerability scan to get common vulnerability IDs associated with the services listening on those ports. And with those IDs, we call the vulner CVE API to get details about that vulnerability. So what it actually means and the implications it has. And then we can store those details in our own vector store so that later on we can pull from our own knowledge base rather than using the API. And all this is to implement or to perform the React loop in the top right. Now, we can see this in action when we go to our agent log from the demo before. It starts off saying I need to identify a host. It performs the ping sweep. It sees the active host, and now it knows that it needs to do a port scan, so it does a port scan. It sees a long list of open ports. With that list, it says, now I need to look for vulnerabilities on those ports. So it starts with the first port and it does a scan on the port. And now with that port, it is given a list of common vulnerability IDs, and it loops through all of those IDs to fetch the details about that vulnerability. So this is the React loop in action. To wrap up here, I'm going to talk about what ThreatScope does well and what could be improved. The system performs well at translating dense, raw network scans into human-readable security reports that offer remediation advice to users. One thing that could be improved, though, is that I could take a multi-agent approach instead of a single agent approach in order to reduce token noise flooding the single agent's context window. For this demo, the number of loops that the agent can perform is limited, but once it gets high enough, you start seeing weird outputs and hallucinations, and so that could definitely be improved upon. But that is all for the video. I hope that it was insightful, and I hope ThreatScope can be useful to you.